Same context as what you just saw in the previous section, only the last one was linear and this one's quadratic, which creates a situation where we're going to have to restrict the domain, which is already built into the problem. Given g of x equals 1/2 x squared plus 3 for x greater than or equal to 0. Okay, the only inputs I'm allowed into this function are the ones greater than or equal to 0. Let me show you what this looks like graphically. This function, ignoring the rest of this, would look like, whoops, you better behave. Not like that. Let's fix that. It would look like this a little bit. That side's off, but okay. So we would deal with, it would look like that. And its inverse, if we truly just switched all the x and y values, would, you better behave, would look like that. Let's get that one point out of the way there. Okay? Well, that creates a problem for that green graph that is the inverse, because that inverse is not an inverse function. It doesn't pass the vertical line test, which means basically if I picked a point out here like 5, I would have 2 possible outputs for that one input, and that's not a function at all. Okay? So because of that, they have restricted the domain from the very beginning. So the only inputs that I'm allowed are x values greater than or equal to 0, which makes the original graph look like this, which makes the inverse graph look like that, and now it is truly a function. Okay, this is the graph of a parabola, half a parabola. This is the graph of a square root function, which makes sense. If I wanted to undo a squared, I'd do a square root. Okay, so let's find the inverse, and let's skip a step or two. The original would be y equals 1/2 x squared plus 3. Let's switch x and y. That would make x equals 1/2 y squared plus 3. And we'll get more in depth with how to solve the ones that are a little more complicated. But here's a really quick explanation. Reverse the order of operations. Order of operations would have addition and subtraction last, but in the process of solving, you do it first. So we're going to subtract 3 first from both sides. It's gone. We have 1/2 y squared. If you want to get sloppy, you could divide by 1/2. Nobody likes that. That's written very sloppily. I will show the work on this part. We're going to multiply by 2. Multiply by the reciprocal makes it much cleaner. Trust me, I know. I do this for a living. We're going to double that side as well. Double the entire side, not just the x. I knew a guy that didn't do that once. He made a terrible, tragic mistake. 2x minus 6 equals y squared. And then we're going to take the square root, because we're solving, right? So the opposite of squaring is square rooting. Let's skip a step. So we have 2x minus 6. I would write equals y, but what we've truly found is the inverse. So let's write it like the inverse that it is. There we go. We have just found the inverse. Now we're going to work through these 3 problems. And these 3 problems involve a function composed of its inverse or an inverse composed of its original function. It's one of those situations. Okay, so we have g of g inverse of 11. So what we're going to do is, let's go green on this. What we're going to do is plug an 11 into the inverse function right there, and we're going to crank out an answer. And then we're going to take that answer and plug it into the g function. So, well, first of all, let's fix this g. The tail end of it is not right. There we go. All better now. So what we're going to do is take 11, plug it into the inverse. Again, this g to the -1, that does not represent anything that you need to do mathematically. Don't be like, I've got to raise this to the -1. No, it just tells you what function you're looking at. Okay? So I have g, because he's on the outside, and he waits, because that's what we do with composite functions. And so we're going to plug an 11 in there, and we're going to have 2 times 11 minus 6. It is all square rooted. And we'll crank that out really quickly. It's 22 minus 6, that's 16. That's the square root of 16, which is 4. Now I want to find out what g of 4 is. I'm going to plug a 4 in right up there, and that's going to give me 1/2 times 4 squared, and then plus 3. So 4 squared is 16. Half of that would be 8. 8 plus 3 is 11. I'm not surprised, and you're not either, because you saw this on the previous problem. It was just less work. The last problem was like x plus 5 and x minus 5, and you add and subtract 5 and you get what you had to start with. It's that kind of deal. Well, now we have other things involved, but I started with an 11, I get an 11, as long as I have a function composed of its inverse or an inverse composed of its function. Okay, you know the answer to this is 2, right? Let's do it quickly, very quickly. You know the answer to this one's x, but I do want to show the work on that one for sure. By the way, let me point out, this is g of 2. because 2 is greater than 0 or equal to 0. So therefore, I'm able to use it. Okay, so I only can have inputs into the g function that are positive. Just saying, because they restricted the domain. We've been through that. So we have g inverse of g of 2. So 2 is going to go right here. We have 1/2 2 squared plus 3. So that's 4. Half of that's 2. 2 plus 3 is 5. We have g inverse of 5. We're going to plug a 5 in and see what we get. We better get a 2. If we don't, we're wrong. So 5 is going to go right there. We're going to have the square root of 2 times 5 minus 6. That's going to give me the square root of 10 minus 6. That's the square root of 4, which is 2. It works. Okay, now we get to the crazy one where we have g inverse of g. And I'm going to scooch this up, and I'm going to change colors. Let's go purple just for fun. So g inverse waits. Waits for what? It waits until I figure out, that's an ugly parenthesis. Not to body shame the parenthesis, but there we go. All right, g inverse is going to wait until we can figure out what g of x is. Well, there's no figuring out to do. We know g of x is 1/2 x squared plus 3. So let's just write that. 1/2 x squared plus 3. So g of x is that. They gave it to us, so there's really nothing to do. But now things get a little tricky because what I'm going to do, and let's use a highlighter for this. This is my input. And that input is going to go in the g inverse function where the input should go, which would be right there. So that is about all of it. It's about to go right there in the place of x. So let's do it. So I'm going to have the square root of. Okay, now am I going to write g inverse? No, because I am now using g inverse. Here it was just waiting, and now I'm like, okay, let's plug it in. So it's getting plugged in to the input right there, all of that. So we have 2 times all of that minus 6. And when I say all of that, I mean all of that. So 1/2 x squared plus 3. And we're going to simplify this thing until we get what I hope is x. If it's not, somebody messed up. Okay, let's go. Let's go ahead and distribute. We're going to have 2 times 1/2. Well, that's 1 x squared. 2 times 3 is 6. And then we already had this minus 6. You can see where this is going already, right? They gone. And we have the square root of x squared. Well, the square root of x squared is x because they undo each other, and it works.